Hello folks, welcome to my channel and welcome to this part 5 of this asynchronous programming. So in this what we are going to see, we are going to launch a task on the completion of another task with the help of this completion stage APIs. We will also see some features of the completion stage APIs when we trigger a task on the completion of another task. Let's switch to the IDE. So this is our part 4 code. If you have not watched my previous part 1, part 2, part 3 and part 4, I suggest to watch that first and then come to this video. Also, the previous part I have provided the link in the top right corner. You could see somewhere there. So let's see what we have done in the previous part. So we have all the suppliers, 5 suppliers, and then we have a task. We just created a list of suppliers and just put all those tasks in it, and then we have submitted these tasks to our completion stage APIs, collected all the feature which we received. Sorry, it's completable feature which we received. When we submit our task to this completable feature, we have collected that, and then we have created our quotation array list, and then we have find the best quotation. But there is some problem here, and what's the problem? The problem is at line number here. This is basically a some kind of a blocking call, and we need to really avoid this kind of a blocking call. And also what we could see here, we do launch our task asynchronously at line number 78. This task is being executed asynchronously, but the problem here is that the main thread now waits at line number 84 for all those tasks to get completed, and because of this code is not okay. We need to do something about it. We need to get rid of this blocking call, and the completion stage APIs has been designed in such a way to make sure that we could really avoid these kind of a blocking calls, and we will precisely see how we could do this. Let me get rid of these lines of codes, and let me see how what we could do to avoid this kind of a blocking call at line number 84. So we have this feature, and then what we could do, we could have a very handy method thenAccept. And by the way, this method is not on the future, this is only on the completable future. And to make sure we just have a proper convention of naming, let me have this completable future. We have this thenAccept, and what I need to do, it's basically a accept a consumer. So let me just provide a consumer, and let me get rid of all these things, and let us run this program and see what happens. Okay, let me get rid of all these two things, and what we could see clearly, nothing has been printed. And why so? We have to think about it, and let me explain why nothing has been printed here. We have submitted our task in this completable feature supply async. It returned immediately, and this task we know that it's going to be executed asynchronously, and of course this task is taking somewhere around 450 to 500 milliseconds. And what we have done, we have changed this feature with this thenAccept method. We have provided one of the lambda expression. Of course this lambda is a consumer, and then once the feature has been finished, we are going to execute our this task. But what happening, but the main method has completed here, it has written immediately, and the main thread did not give a chance for all these tasks to get completed. So that's why we do not see anything here. But if we have to see the result, what we need to do, we could sleep for at least 600 milliseconds, because we know that all our tasks will get executed before 600 milliseconds. And if we do that, then we should able to see our results, and we could clearly see all our 5 quotations have been executed successfully. The future has been resolved here. But this doesn't look nice. What we could do better here is, of course, return some kind of a completable future. I could just say result, and if you clearly see, we have a completable future void. I could have a list of array list of completable future, and this could be a void. Let's name this as voids, and why not new array list. And I could just add all my results which are of type computable feature of void to this, and then I could just run my for loop, iterate over this list, and r.join, and we could get rid of this sleep method. Now if we run, we could clearly see all our quotations have been executed, because this is a blocking call, but this is not a part of my application. It's just that so that we could see the result. Okay, that's great. Now what we want to do, we want to add all our computable feature results in this quotation array list. So what we have to do, this is very simple. This thenAccept, of course, it takes a consumer. Let's replace with some kind of a lambda expression, quotation, and I really need to add to this array list quotation dot add, and I could add my quotation here. But wait a minute, we need to understand in which thread this lambda expression is going to get executed, and it's going to get executed on some kind of a fork join pool, one of the thread from the fork join pool. Even if we provide an external executor services, still this lambda will be executed in some other thread, a thread from the executor service pool. But yes, it's going to be executed asynchronously and in some other thread. And because of that, we could have a lot of race condition here, because this array list is not concurrent aware, and we may get into trouble, maybe not in our code, but definitely in the production we are going to get into trouble. So we need to make sure this array list is concurrent aware. So let me just have some kind of a concurrent aware here, concurrent link DAC. Yes, I am happy with this concurrent link DAC. This is some kind of a collection, and then and this has now become thread safe, and I think so we are done with here. We need to have this join call again here, and now we could again run this and check. Let me just print out my system.out.println of this list. Let me print out here first quotations, and let us run this program again. And clearly we have seen that the quotation is empty. And why so? Again the same issue we have. All these tasks are taking 450 to 500 milliseconds, and then once the task has been completed, we are adding, with the help of this thenAccept, which accept the consumer, we are adding all these results to our quotation array list. But our main thread has exited very early, and it didn't give a chance to add all these tasks in my quotations. It just print this quotation empty because no task has been completed, nothing has been added in this quotation array list. But if we do this, we just take this out from here and do here, because we know that all our task has been completed by this line number 92. We should get something in the quotations. We should get all the task completion here, and we have seen we have all these 5 here. And now what we have to do it, we just need to have the same early code, simple stream APIs, and we could just uncomment all this code. Now we could run to get our best quotation, and yes, we have got our best quotation here. We can get rid of this. One final thing I want to say here, all these methods, they return immediately, just like in line number 78. As soon as we submitted this task, it return immediately. The main thread return immediately. Similarly, when we say we have changed this our future with this thenAccept, it still return immediately, and the main thread is basically not at all waiting for the completion of these tasks. And our this line, as I've said, we have made sure our main thread is waiting at here so that we could really show the result. But this will never be a part of my application when I am doing in some kind of a Spring framework. I hope you got the gist of this video. In the coming videos, we are going to create pipelines of asynchronous tasks with the help of these computable future APIs. Till then, bye bye. Please like this video, subscribe to my channel, and also share this video to all your friends who are Java enthusiasts and who wants to learn asynchronous kind of a programming.